interface on R1 belongs to a certain area. These two devices you want to establish a relationship with. Their interconnection interfaces must be in the same zone. So the area code must be the same for the entire NA stage. All the configuration we have done now, they were all done in the same area. Let's get acquainted with the basic configuration. So this is what we call the conditions for establishing a neighbor relationship. For OSPF, this area code is also called area. It has a rule. Area code if the same, then the same region. If the area code is different regions. LSA has a synchronization. A prerequisite for synchronization is must be in the same region. LSDB will not be synchronized if different regions. And we are currently learning. We will study the backbone area. The backbone area is area 0. Then there are non-backbone areas. That is, any area other than area 0. You can also define your own. A non-backbone area is a non-area 0. This is the third parameter. Area code. Down to the last one. It cannot be said to be a parameter. It can only be said to be an action. For OSPF, let's build a neighbor relationship. It is necessary to use the interface. In fact, EIGRP is the same. They are all through the interface. So how to put the interface in OSPF? This is also called network. We will also configure it today. There are two ways to build a relationship. One method is called the declaration under the region, or called under the process of declaration. Its overall configuration format is the same as EIGRP. Declare a directly connected network segment between the two, followed by a wildcard mask. At this stage, we can understand it according to the anti-mask. Or, we enable OSPF under one interface. It is also equivalent to declaring it. These are two different ways. In fact, there are no more parameters. We will start to look at several states next. Just now there are messages and statuses in the PPT. Let's take a look at this state first. In addition to the 5 types of messages we just mentioned, the state is also something we have to learn. For equipment, there are 8 states. Among them, we will not discuss this attempt now, because it's almost unheard of now. There is no application scenario for it. So we call OSPF 7 states. By default this will not be mentioned. OSPF was created earlier. It supports many ancient network types. Well, like this NBMA and frame relay. This environment is no longer seen. In fact, there are very few point-to-point operating OSPF. Early OSPF was applicable to multiple link types. It can support. Then let's look at the remaining states. First look at down, followed by init. Is now called initialization. Then two-way. It is equivalent to a watershed. Further down is xstart. The next one is exchange. Next is loading. The last one is full. Okay. Let's explain them one by one. These are the 7 states. In the process of message exchange, the state will be switched. So how do we switch the state? Let's look at the 5 messages. This part of the message is a bit boring, so please pay attention. Let's talk about the hello packet first. I have told you about the hello message. If I want devices to learn from each other the network segment behind it, first they have to establish a relationship. That is, R1 is now announcing their directly connected network segments, or declare its interface. Declare into area 0. Then when it is announced now, this interface will send a hello message to the outside world. Then it is in the process of sending the hello message. For example, R2 has not been released yet. R1 is sending out. This process is actually the sending process of the hello message. So now R1 is declared finished. The R2 interface is also open. Declare it too. Let it also start sending hello packets. Then both R1 and R2 have received the hello message from each other. Then an OSPF relationship can be established between them. But for devices, for example, now there are two devices. One on the left, one on the right. There is a line between them. This is device 1. This is device 2. So how does this state switch? First of all, they exchange hello packets. Then please pay attention. At the beginning they are all down. This neighbor state machine means the device sees the status of neighbors on its own device. Like the message we just saw. I don't know if you've noticed. This is the state of the neighbor. This is the state of the interface. This full is. R1 is on this device. C2.2.2.2 the interface between this device and R1 to establish a neighbor. Whether they are neighbors. There is no interaction when the device is just turned on. They do not start running OSPF. They are actually down. For now, device 1 is running OSPF. Then I configure an address for it here. 1.1.1.1. Device 2 is 1.1.1.2. Now that the device is powered on, device 1 starts sending hello packets to the outside world. Then this hello message will be sent to device 2. As long as the interface declares, device 1 starts sending. This packet is then sent to device 2. Please pay attention. When device 1 first started sending, since device 2 hadn't been announced at the time, so device 1 is sending out to introduce itself. When device 2 is also running, it received this hello packet from its own interface. The content inside is the information that device 1 is describing itself. Then if device 2 receives you will learn the structure in the hello packet in the future. The hello data packet will carry the router ID parameter. In details, it can see that there is a device 1 in the current environment, including the information of the interface of device 1. Device 2 sees both. Then now device 2 will switch device 1 to the next state. When it looks at device 1 locally, the device 1 it sees is the second state at this time, called init. So now device 2 is equivalent to receiving. Same. After device 2 is turned on. After running OSPF, the hello data packet should also be sent out. So at about the same time, device 1 will also receive the hello message from device 2. Then it will also set device 2 to the init state at this time. And the following state. When the device receives the message for the first time, everyone must first be clear. For example, device 1 sends only itself. Device 2 only sends messages to itself. Then when a certain moment, device 1 receives the hello packet from device 2. Device 1 is now running OSPF. Suddenly received a hello data packet sent to it by other devices. Tell it the interface address is 1.1.1.2. Router ID is 2.2.2.2. It knows now. A device came into the environment and wants to establish a neighbor with it. So now it will send hello packet.